Here we're doing section 9.3, problem number 2 from the book. We need to find out what the solutions to this equation are using the quadratic formula. So first we need to make sure it's in quadratic form, which means that we have an x squared term, an x term, and a constant term, that they're all on the same side of the equation, and that the other side has 0. So this is in quadratic form. We then need to outline what a, b, and c are. So a is the coefficient of the x squared term. B is the coefficient of the x term. Don't forget your signs. And C is is your constant term. So we have A, B, and C. We then need to plug these into the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c. All of that is under the radical. And then the whole thing is divided by 2 times a. Now we need to substitute a, b, and c with their signs in for each one of these. So we have x equals negative b, and so it's negative 7. Plus or minus the square root of b squared, so that's negative 7 squared. Minus 4 times a, which is 2, times c, which is minus 9. And we divide that whole thing by 2 times a, which is 2. Now we simplify where we can. Just simplify. So we get x equals negative 7. That's 2 negatives in a row. That gives us positive 7. Plus or minus the square root of negative 7 squared is positive 49. Remember, this is negative 7 times negative 7, which becomes positive. Minus 4 times 2, which is 8, times minus 9 is a minus 72. All over 2 times 2, which is 4. So we have a minus here. This becomes plus. So x is going to equal 7 plus or minus the square root of 49 plus 72 is 121. All over 4. 121 is a perfect square. It's 11 squared, so we can rewrite this as 7 plus or minus 11 over 4. And then we need to split this up into 2 equations. One that has the plus sign, one that has the minus sign. So we have x equals 7 plus 11 over 4, and x equals 7 minus 11 over 4. So 7 plus 11 over 4 is 18 over 4, which can be reduced to 9 over 2. 7 minus 11 over 4 is minus 4 over 4, which can be reduced to minus 1. So we find that solutions for x that satisfy this equation are at when x equals 9 over 2 and when x equals negative 1.